So we have compute index, then we pass in the name and the size of the hash array. Now, the problem is now how to hash the string and get the number. We have different hashing algorithms for that, but the compute index function is not the actual hash function, but it makes use of the hash function in our case. So the hash function is not the same as this function. This function is only for determining the index, and it makes use of the hash function. So now we have to decide which hashing algorithm um, we need for this example. So what happened, the function doesn't exist yet, but we're going to have it. What happened is that this compute index will call the hash function. So it will say, let's say we call it hash, and we pass in a string. The hash function takes up a string. Then the hash function return a number based on the string we passed in it. Then we take that number and we calculate, we say modulus size. So this will return a value between 0 and size -1. So these are the index. So if we have a size of 50, that means the first index start from 0 and the last index is 49. So the hash function return a number from the string, and we can take the mod to get the index. The hash function doesn't exist yet. I'm going to call it hash it. So hash it. Let's create the hash function. For now, I'm going to say unsigned hash it. It takes out the name and return an unsigned integer. So I don't know which hashing algorithm we need to use now, but let's do some small search. I'm going to go on Google. I don't quite remember the hashing algorithm we've been using.
Boss, can we try the one?
Yes.
Can we try the one that the internet suggested?
Yes, I forgot the name. Can you tell me the name so I can search it on Google now?
Okay.
The name, so can search.
I think it was like DG.
DG.
Let me.
D.
I think it was DG or DJ hash algorithm.
DJ hash algorithm. Hash algorithm. Okay, I'll go. So I'm looking for this stage of thing. I don't see it, but let's say I'm gonna say hashing, hash algorithm, hash algorithm for hash tables. Okay. And what we got here, we may find the name.
Yeah, it's called DJB2.
DJ.
DJB2 function.
DJB2 JB
DJB2.
DJB
Two.
DJB2 uh DJ it um
Hash function.
uh, okay, let's see. I'm just going to copy it from a repository. The codes are the same, I
Yeah, the
guess.
yeah the GitHub one.
Yes, we have this thing here, unsigned long. I don't know if there are other implementation different than this, but let's search for it. Oh, it's the same, unsigned long. It's the same, so I'm just going to copy it and pass it in our code. Just copy it here. Let's go back in the code and let's create a hash function, hash.c. It says number of buckets. No, this seems not be. What is the hash function? I guess where does these constants coming from? So I'm copying it from this site. They return the hash. So there are a lot of possible algorithms. So they have kind of three algorithms here. Just going to copy it and pass it in our code. So DJ, um, but in the code we call it hash it from the main header file. Or let's keep the thing simple. Let's keep it simple. So we have hash. So the hash function takes up a string and return an unsigned long, which means the index also should be unsigned long. The size, we're going to say it is unsigned longs, just updating the prototypes. So we have this hash function. It takes up a random string and turn it into a number we can use. So here we call the hash function on the name. Then we take the modulus with the size of the hash table. So the hash function, it's like we kind of cannot predict easily what it's going to return. But what we're sure about, the collisions might happen means that for different input, the hash function might return the same number, or in our case here, it might return the same index. So if it returns the same index, then we add it to the list. Uh, we add the item to the, we add or updates on the corresponding list. Now inside here, let's return. So we call this compute index function, and it will pass the milk. It will pass in the milk. Why? Okay, this is unsigned long. And here too, we have unsigned long, the type of size. Okay, so now the compute index takes up the string and the size and will decide which the index it passes it to the hash function. The hash function return a number. Then we compute the index. We return the index. So the return index from the compute index function will be the index of the list we're interested in. So we take the list, then we add or update a product on that list. So basically, this is the hash array. Now we need to add some other things to make it more easy to use. Yes, it's this. Someone asks whether the hash function code we can put it put the code in the compute index function. Yes, we can. But we keep things separated just to have a more organized code. So each things have different purpose. Maybe later someone might decide I want to use another hash function. So they might decide to change the hash function implementation. So this is only to make the code more organized. And also this is why we don't need to create all these files actually, but it makes the code more easy to read. Um, Someone asked if the hash function and the compute index return index. Uh, no, the hash function takes up the string and return, let's say, a random number. It's not random, but let's say it is very hard to guess. So it returns some kind of random number, and we take this random number, then we compute uh, the index from that random number. So then the random number can be, let's say, 1,000, 1 million. But when we do the modulus, we always get a number that is in the range of the available indexes. So the hash function return a number, a random number, we can say a very hard number to guess, a number very hard to guess. Then we take that number, then we compute the index. This is why uh, here we decided to separate the content of the two functions, just to uh, just to show that these two functions are not doing the same thing. They have different purpose, I want to say. So, okay, we've been able to add a product to the list. Uh, okay, what makes sure the number is in the range? Uh, yes. So when you the computer modulus, it returns the rest of the division. So if the number is high enough or greater than size, it will return the remainder of the division, and the remainder is always smaller, or is always let's say lower than the, the how do we call it, the divider. Yes, it always return 0, a value between 0 and size minus 1. True. So this is how we make sure the index is always in the right range. Okay. Now let's go back into our array. So we know now how the hash arrays, the hash tables works. So a hash table is basically that, an array of list, and we have a hash function that help us decide to which list the next or the new node has to be added. Now here we have something, we're going to make the code a bit more structured. So for that, I'm gonna say uh, go in the main header file, okay, and add a new struct. And this new struct, I'm gonna call it, um, the name can be whatever. We can call it database. It doesn't make sense, but let's say it is, let's say a dictionary, okay, a dictionary of product. I'm gonna create a type table, a struct type, and the struct type will be dictionary. Um, Another name, we can have a name that makes more sense. Okay, we're going to call it catalog. I think that makes sense. I'm going to define a new type called catalog, and this will be a catalog type. So it is a catalog of products. As we said, the name is not important, but the structure is. The name helps us to work in the context. Here we're working with product catalogs, but the data structure is the things that we need in to understand. So here we define a catalog, uh, a catalog struct that represents a list of a hash table or a catalog of the products, and the structure of this catalog is a hash table. So I'm gonna say the size. We're going to add a size field, meaning the size of the array. I'm gonna say ARR size. So the catalog and the array inside the catalog are not the same. So here we have an array of products, and we can create a new catalog, or we can just say set the size manually, but I don't think. We're just going to create the array dynamically. So we need to have some other functions, create catalog and delete catalog, add product to catalog, these kind of functions. Then we have a new struct, and we're going to add these functions. So I'm gonna call it new catalog, C, and we're going to add some other functions. So what I want to do is to make these things more readable. I'm gonna add this. Oh, sorry. I'm gonna scroll down here. Yes, add these things. Define the struct and add in the functions. So here we have new catalog. So a catalog type, new catalog. So with the new catalog, we pass in the size. So unsigned long size. So this is the size. We create a catalog of size. Or it's not the size of the catalog, but the array size of the field member named array size. And all these fields, I'm gonna just make them what I'm gonna call it. Yes, underscore array. These are not fields intended, but some important fields might be the number of product in the catalog. These are interesting fields, so we can access them directly. The num of products. Okay, when we create, so we're interested in the number of elements or product in the catalog. So we don't add an underscore because this is the actual data we need. But this thing called array size is only to build the data structure. Now, next thing is void. We have create catalog. Then we have delete catalog. We pass in the catalog. Since we're deleting the catalog, I'm gonna call it cat. With deleting the catalog, we need to pass in the address. Okay. We might need to add some other things. Add product in catalog or insert or catalog add product, something like that. Just to add new products in the catalog. So void add, or we're gonna say cat add product. Then we pass in the catalog. So catalog. Then we pass in the name of the product we want to add in. And also we need to pass in the price. Okay. So what we're doing here, we are building data structures on top of other data structures. So we're building the hash array or the hash table on top of the static arrays and on top of the list. So this is what we need to understand. And the next thing is we might want to search for a product from within the catalog. We have cat search product by name. So we pass in the catalog. Since we're not modifying the catalog, we're only passing the pointer to the catalog. And next, next thing is we pass in the name. So the name of the product we're looking for. So this function should return the product. And we know how to create a catalog. It's time to delete a catalog. So catalog void delete catalog. So here we pass in a catalog, a pointer to a pointer, because the delete function is going to delete the catalog and set the variable to null. I forgot to add some other things here. The field product array of the catalog. We need to make it, since it is an array of pointers, so we need to add an additional start just to represent, so it can hold a reference to an array of list of product. Okay, someone asked the question, the num of products added field, the num of product fields will be updated whenever a new product is added to the catalog, but not when a new list is added. The number of lists are already known when the catalogs get created. So the num of product depends on the number of nodes we add in the catalog, but not on the number of lists, because each list may hold a variable number of products inside this hash table data structure. So and num of product depends uh, on the number of nodes added in the nodes added, but not on the number of lists. The number of lists is already known. Let's go ahead and create this function. Instead of say cat, I'm gonna say catalog. The names are lengthy, um, but just for the purpose of this example. Okay, let's now create a new catalog. I'm gonna create a file, catalog. Let's see. Oh, it's already there. It's here. Okay. Now the prototype. So a catalog, the structure of a catalog is of type hash array. Okay, the video will be available on YouTube, so you can watch it later. Thank you. So here we have this new catalog function things, and we're gonna create a catalog type. It will return a pointer to a new catalog, and we pass in unsigned long array size. So this is the size of the hash array. Then the next thing, we need to import the stdlib library, because we're gonna do some dynamic memory allocations. And here, what do? We create we create a new catalog. So catalog type T, new cat. Then we call the malloc function size of catalog, catalog type T. Okay. Then we check if the catalog is being created successfully, new cat. If new cat equal to 0, null, we return null because the creation wasn't successful. So for those who have meetings, the video will still be available. We're just gonna make sure that this part ends, but the video is going to be available. Still, if any question, the question can be asked in the chat or interrupt. So we have the new cat, and then the new catalog, if created, we need to set the array field. So the size of the hash arrays inside. I want to rename these fields. I'm going to just say array of list. I'm going to rename it. So then array size. I think that makes more sense. So we'd have array size equal array size, and then the new catalog will be someone asked the question. Okay, it's much better. So we have the array size. So this data structure we have here, the catalog, it is a struct, but we have the internal structure, the field needed to represent the internal structures start with the underscore. So we have to understand there is a difference between the data and uh, the custom fields we added in order to support different data structures. So here for the catalog, we want to support the hash array um, data, the hash table data structure. So we've been able to create the catalog. Now it's time to create the array of list. So what happens next is we have the new catalog, then we have array of list, then we have to create the array needed to store the list of arrays. So that will be size of product type pointer. So each element in this array represent a pointer to a product. So it represents the list time the array size. We also need to make sure that the allocation was successful. So if the list of array is equal to null, that means the allocation failed. Then what we need to do, we need to return null. But before we return null, we have to free up the already allocated memory location. So I'm gonna say free new cat before we return. Uh, yes, the products T structs has already been made. It's here, and from the previous recording we made, all the recording are going to be available on the YouTube channel. So we described how these product structs has been created, and so now we have a product catalog. Now we want to support. We want to give an example where we can showcase support for hash tables. So here, when the allocation for a new catalog fail, then we need to return a new, we need to free up the, no, I want to say, when the allocation of the array of list failed, and then we need to free up the already allocated memory, then return null. But if not, we need to set the elements of the array to null because all the pointers are initialized to null first because there is no element in the list. So for that, I'm gonna declare a new variable named I unsigned int unsigned long I equals 0, and we say for so while I is lesser than array size, then we say new cat array of list, then we set them to null, then I plus plus. Then after all the pointers to list are set to null, we can return the catalog. Now, another question is, so we will have an array of pointers to product nodes all set to null, correct? Yes. So here we'll have an array of pointers all set to null. So it's basically each element in the array represents a list. And now we're good to go. There have been uh, there are also questions we received from the chat group, like why not use the callout function. We can avoid using this loop here. We can call the callout function. The callout functions allocate a memory and sets all the bits to 0, which means the array or the allocated memory location is all the elements are already set to null the moment the callout function return. But here, just to show the process, we create the malloc, we use the malloc function and set all the pointers to list, all the list pointers to null. So that is for the catalog. The next thing is delete catalog. So how to delete the catalog? We already had a prototype. We have the catalog here. Oh, I forgot to set the name of product field to 0 because when the catalog is created, the name of product is set to 0. Yeah, the catalog is, it is not, well, I can say um, it's not the actual hash table, but the internal structure is a hash table. So we have the data, but the way the data is structured from inside. So we choose to use the hash table data structure. This is why we have these two fields. One field to store to have the arrays. This is the actual hash table, the array of list, and but we can